Hello viewers, I'm Kausalya. Today we are going to solve problems 7, 8, 9 and 10 in exercise 7.2 in the chapter Coordinate Geometry. So problem number 7. Find the coordinates of a point A where AB is the diameter of the circle whose center is 2, minus 3 and B is 1, 4. So here we are going to discuss about a circle. So this is the circle and the diameter is given. So here we need to find the point A. That is, we are going to find the coordinates of point A provided the other end is given. Okay, B is 1, 4 and the midpoint, right, or the center of the diameter is given. It is 2, minus 3, right? So here the thing is we have to find the coordinates of A. So here we know the value of other two parts. Once the value of the midpoint is given, obviously we have to make use of the midpoint formula. So what is the midpoint formula? It is x1 plus x2 by 2, y1 plus y2 by 2. Right? So the midpoint is 2, minus 3. So this is again x1, y1 and this is our x2, y2. So we are going to substitute the values. So x1 plus x2. So here it is x plus 1 by 2 and y1 plus y2. Here it is y plus 4 by 2. Right. So now we are going to equate the terms. So x plus 1 by 2 is equal to 2 and y plus 4 by 2 is equal to minus 3. Right. So x plus 1 is equal to 2 into 2 becomes 4 and x is nothing but 4 minus 1 which is equal to 3. Right. I am moving this plus 1 to the left hand side, therefore it becomes minus. Now we are equating the second term, that is minus 3 is equal to y plus 4 by 2. So minus 3, when I move this 2 over here, it becomes minus 3 into 2, therefore minus 6 is equal to y plus 4. Therefore y is equal to minus 6 minus 4 which is minus 10. Right. So coordinates of A is nothing but x, y which is 3, minus 10. So next problem number 8. If A and B are respectively, find the coordinates of P such that AP is equal to 3 by 7 AB and P lies on the line segment AB. So here AB, that is a line segment, is given, right? The values of A is minus 2, minus 2 and B is 2, minus 4, right? And there is a point P, right, such that AP is equal to 3 by 7 times of AB, right? So there is a point P, I don't know where it is, so let it be here, right? P of x, y, and it holds in the relationship AP is equal to 3 by 7 AB, right? And P lies on the line segment AB, right? So AB is a line segment and P is a point that lies on the line segment, and the relationship between this AP and AB is given by this part. Okay, AP is equal to 3 by 7 times of AB. Now we are going to find the value of this P, right? So first we go with the given relation. AP is equal to 3 by 7 times of AB. So when you look at this diagram, you see AB can be written as, this is our point B, right? AB can be written as AP plus PB, right? So I am writing this AP plus PB. Now I am doing a, just we are going to make some arrangements. I am moving the 7 to this left hand side. So this denominator 7 becomes a multiple over here. So 7 AP is equal to, I am multiplying this 3 with the terms inside the bracket. So 3 AP plus 3 BP, right? Now I am combining the AP terms together. So when I move this 3 AP to the left hand side, what does it becomes? 3 AP minus 3 AP is equal to 3 PB, right? So 7 minus 3 becomes 4. So 4 AP is equal to 3 BP. So again I am making a ratio, AP by PB is equal to 3 by 4. Right, just we are rearranging the terms and making a ratio. That's it. So here what does this denotes? AP is 3 and this PB is 4. So again, when you look at this AP, okay, AP is 3 and this PB is 4, right? Now we are going to make use of the section formula to find the value of P. So x comma y is given by m1 x2 plus m2 x1 divided by m1 plus m2, and here m1 y2 plus m2 y1 divided by m1 plus m2, right? And the ratio here is m1 is to m2, which is 3 is to 4. Now we know the values, right? A is given by minus 2 comma minus 2 and B is given by 2 comma minus 4. So A gives x1 y1 and B gives x2 y2, and we know the value of m1 and m2. So just we are multiplying, you see, m1 x2. So here is 3. 3 into 2 plus m2 is 4, right? 4 into minus 2 divided by 3 plus 4. The same way here, m1 is 3 into y2. y2 is minus 4 plus m2 is 4 and y1 is minus 2 divided by 3 plus 4. So once you simplify, you see 3 2s are 6 and 4 into minus 2 gives minus 8 divided by 3 plus 4 is 7. And here 3 into minus 4 is minus 12. 4 into minus 2 is minus 8 by 7. So here it is 6 minus 8 is minus 2 by 7, and minus 12 minus 8 gives minus 20. So minus 20 by 7. So finally the coordinates of P is minus 2 by 7 comma minus 20 by 7. Right. Here the thing is a relationship is given. From the relationship we have already found out the ratio, that is the value of m1 and m2, right? That is the difference between the other problem and this one. So next, problem number 9. Find the coordinates of the points which divide the line segment AB into 4 equal parts. So here we have a line segment AB. This is divided into 4 equal parts, right? That is AP is one part, PQ is one, QR is one, and this RB is one. All these 4 parts are equal, right? Therefore, AP is equal to PQ is equal to QR is equal to RB, right? Now, the thing is, we are going to find the values of this P, Q and R, right? Find the coordinates of the points. So here we have to find the coordinates of P, Q and R. So first I am taking P. So when you took P, you see what is AP? AP is 1 because each are equal, and this AP stands for this one part, right? 1. And this PQ stands for other one, QR other one, and RB other one. So when you consider the point P, that is the entire line is divided like this. That is, this is my A and this is my point P, and finally this is my point B. So how this line is divided? This is divided in the ratio 1 is to 3. Right, this is what the line is divided. So here just this is my m1 and this is my m2. So you see the point P of x1 comma y1 divides AB in the ratio 1 is to 3. This is what this means, right? So again, making use of the formula, x1 y1 is equal to m1 x2 plus m2 x1 by m1 plus m2, m1 y2 plus m2 y1 by m1 plus m2. So here we know the values of m1, m2, and here you see my point is A and B. So A gives x1 y1, B gives x2 y2. So m1 is 1. 1 into x2. x2 is 2, right? 1 into 2 plus again 3 into minus 2 divided by 1 plus 3. Same here, 1 into 8, right? Plus 3 into this 2 divided by m1 plus m2. So 1 into 2 is 2 and 3 into minus 2 is minus 6 by 1 plus 3, 4. And here it is 8 plus 6 by 4. So 2 minus 6 is minus 4 by 4 and 8 plus 6 is 14 by 4. So here the answer is minus 1 comma 7 by 2. This is the point P. Right. Now we are going to find the value of Q. So again we are going to consider the same line, right? You see here, this is my point A, this is my point B, and somewhere this is my point Q. So again when you look at the original diagram, you see AQ. So AQ has 2 parts and QB has other 2 parts. So here the ratio is equal, that is AQ gives 2 and this QB gives 2. Right. So this is my M1 and this is my M2. Again, here no need to go with the vertices because it is clear, right? Q is the midpoint. So here we are making use of the midpoint formula. So midpoint is given by, the formula is x1 plus x2 by 2, right, comma y1 plus y2 by 2. This is the midpoint. So here just I know the value of a and b, right? So again wait, let me write it again. Minus 2 comma 2 and the value of b is 2 comma 8, right? So again this is my x1 y1 and this is my x2 and y2. So here x1 plus x2, so minus 2 plus 2 by 2, and here 2 plus 8 by 2. So minus 2 plus 2 becomes 0 and 2 plus 8 is 10, right? 10 by 2. When you simplify, here the answer is 0 comma 5, right? Now we are considering the last point, that is point R. So again, when you draw the diagram, you see this is my A and this is my B, and this is where my point R is located, and here RB is 1 and AR gives the value 3, right? Again you see when you look at this main diagram, now I am considering the point R. So AR gives 3 and this RB gives 1, right? This is the ratio in which it is divided. So you see once you simplify here m1, right? Again we are considering the same, again a and b points. So m1 into x2, so 3 into 2, right? 3 into 2 plus 1 into minus 2 divided by 3 plus 1. The next thing is m1 y2. So m1 is 3. What is y2? Here y2 is 8. So 3 into 8 plus 1 into 2 divided by 3 plus 1. So once you simplify this, 3 2s are 6, right? 6 minus 2 by 4, comma 24 plus 2 by 2. 8 3s are 24. So once you simplify, 6 minus 2 is 4 by 4 and 24 plus 2 is 26 by 4. So 4 by 4 gives 1 and 26 by 4 gives 6. So finally here we have calculated all the values of the points which divides a line segment AB in a particular ratio, right? So this is our last problem in exercise 7.2. Find the area of the rhombus if its vertices are, okay, given, taken in order. So we should take the vertices in this particular order, right? So first draw a rhombus. Let this point be A and let this be B and let this be C and let this be D, right? So here the point is minus 1 comma 4. So area of the rhombus is given by the formula half into product of its diagonals, right? So here what about the diagonals? Here the diagonals are AC and BD, right? So half into AC into BD. So to know the AC, we know the value of two vertices. So here we are going to make use of the distance formula, right? So here the distance formula is given by A of 3 comma 0, C of minus 1 comma 4. So here x1 y1 and x2 y2. So the distance formula is x2 minus x1 square plus y2 minus y1 whole square under the square root. So this is my x2. So x2 minus x1, minus 1 minus 3 the whole square plus 4 minus 0 the whole square. So minus 1 minus 3 gives minus 4. So minus 4 square plus 4 square. So this gives 16 plus 16, which is root of 32. Right. So square root of 32 can be written as 16 into 2. Right. So just for simplifying, we are making use of this. So how to write this 32 as 16 into 2? Just find out the factors. That's it. 2, right? 1 2 is 2. 6 2s are 12. Again 2, 8 2s are 16. 2, 4 2s are 8. So again 2 2s are 4. Right. So these are the factors of 32. That is 1, 2, 3, 4, 5. Totally we have 5 2s. That is, you see, just like this, 2 into 2 into 2 into 2 into 2. Right. So here the thing is, you see, 2 into 2, right? You can write it as 4, and here 2 2s are again 4 into 2. So what is square root of 4? Square root of 4 is 2. And what is this square root of 4? It is again 2. And the square root of 2. Okay, 2 is not a perfect square. So let it be 2 here. So 2 2s are 4, right? So 4 into root 2. This is the thing what I have written like this. Right? In any way you can solve. Now the next thing is BD. So again write down the values of the vertices of B and D. So B gives x1, y1 and D gives x2 and y2. So again we are substituting the terms in the formula x2 minus x1. So minus 2 minus 4 the whole square plus minus 1 minus 5 the whole square. So minus 2 minus 4 is minus 6 and again minus 1 minus 5 is minus 6. So minus 6 square plus minus 6 square. So 36 plus 36 which is square root of 72. Again the same thing what I have did here. You have to find the factors of 72. Again you see, let it be like this. We start from 2, okay, because it's an even number, right? So we go with 2. So 3 2s are 6, remainder 1, 6 2s are 12. So again 2, 1 2 is 2, 8 2s are 16, 2, 9 2s are 18 and again here 3 3s are 9, right? So when you took the root, again you see this 72 can be written as, 2 into 2 into 2 into 3 into 3, right? So here this is under square root because we have to find square root of 72. So again here the thing is we can make it simple, right? 2 2s are 4 and there is only 1 2 left out, write it, and 3 3s are 9. So when you take square root of 4 is 2 and square root of 9 is 3 and this 2 we can't do nothing, so let it be root 2. So 3 2s are 6, so here the answer is 6 root 2, right? So now we have calculated the value of the diagonals AC and BD. So just substitute in the formula. Area of the rhombus is half into diagonal values. That is the first diagonal value you see here it is 4 root 2. So 4 root 2 into 6 root 2, right? Root 2 into root 2 is simply 2, right? And 6 4s are 24. So once you simplify, you see this 2 and 2 get cancelled and the area of the rhombus is 24 square units, right? So that's all in this video. If you have any doubt, let me know in the comment section. Thank you.